In this video, we're going to be going over biochemistry that you have to know for the USA Bio-Olympiad. So first off, let's start off with the 21 amino acids. So first we're going to have the amino acids. With electrically charged side chains. So for a positive charge, we have arginine. The pKa is 12.10. The pKa here is 9.00. But actually, before we discuss this, let's talk about the universal amino acid backbone. So every single amino acid except for proline has this backbone. So it's going to be like H, C, COO minus NH3 plus and H. So what you have is you're going to have your central carbon atom, then after this you're going to have your amino acid group, this can be NH3 plus at a pH of 7, and then you're going to have your carboxylate. And then you're going to have your R group, your side chain. This is what changes. So my tip for you for this is that you ignore the backbone and you focus on identifying this. Now let's start off with the non-polar hydrophobic amino acids. So when you're gonna have glycine, And you can remember that with just it's me GAV. And how you can remember this is that but let's finish drawing out all 21 of the amino acids. Note that this is longer than aspartic acid. Now moving on to the amino acids with polar uncharged side chains. We have and this is going to be HO here, and then you have to this side you have O. You have an NH2 here. You have an NH2 here. You have a pKa of 8.76. And here you have a pKa of 2.16. Glutamine is GLN. And this is going to be HO. You have two double bonded to O here. Down here you have NH2. Here you have this, and then this. And then you have O here. And you have NH2 here. Now we also have some special cases that you have to know. Now, in these special cases, you have cysteine. Represent that as C, and that's going to be HO. Bond here, you have a double bond to O, and then you have NH2. You have here you have SH. You have at a pKa of 8.14. Here you have a pKa of 10.28, and here you have a pKa of 1.91. Now on to our next one. We have selenocysteine, and this is abbreviated as SEC, and this is going to be represented as U, and what you have is, again, hydroxyl up here. You have a SEH here. This is going to be a pKa of 10. This is going to be a pKa of 1.9. Now we have glycine, also abbreviated as GLY. This is going to be a G, and then your G is going to be here you have HO, and this is going to be O here. You have NH2, that's going to be pKa of 9.58. This is going to be a pKa of 2.34. Moving on, we have proline, abbreviated as pro, and we have it as P, and then your pKa for the top is going to be 1.95. I'll move this over here, and there, and then we'll have, again up here, we have a hydroxyl group. This splits into O, and then we have this pentagonal shape, NH, and your pKa is going to be 1047, and this one is built with the hexagon, so you can remember that is different, right? And now those are our special cases. So we have 4 special cases. After this is our last category, so we're almost done. We have our with the hydrophobic side chain. So we first start off with alien, which is ALA. Abbreviate that with A. And then what you have here is HO. It's going to be pKa of 2.33, okay. And here you have O. You have NH2. It's going to be a pKa of 9.71. Okay, now on to our next one. We have isoleucine, which is Ili, and we represent that starting off with another hydroxyl with a pKa of 2.26, and then this is going to go this O. You have an NH2 there. It's going to be your most phobic end. We're almost done. Okay. Just have a few more to go. Now we have leucine, LEU, presented as L. And this is going to be You have hydroxyl. This one is fat. And then finally we have valine. So we first talked about the non-polar hydrophobic amino acid. Now we can talk about the polar amino acids. And so the variation is thir, asin, and we have glyn, and then here we have tyre, and then here you have cis. So some key facts here are that their charge is going to be at pH of 7. Also, you can note that also thir, and also tyre. They are phosphorylation sites. Cytidine is a place of disulfide bonds, and also note that tyrosine is going to be aromatic, but it's not polar. So overall, remember that OH or SH means it's polar and reactive. Now up here for our non-polar, note that glycine is the smallest and it's also flexible. Note that for proline, it also breaks alpha helices. You can also remember this one, actually. I'll just mark it in here. ILE. Now, additionally, methionine is a start codon AUG. Now, you also need to know your acidic negatively charged amino acids. So there's just two. It's aspartic acid and glutamic acid. And remember, it means extra carboxyl. And also they bind to positive residues. They're also often in so remember, D and E equals acidic, and it's like a down charge. So our aspartic acid, let's actually go highlight all these. This is going to be and they're going to have side chains. So drawing this out fully, this will be those are the symbols. Moving this down here. So again, this is asp, this is his glue, and the side chains for each of these. This is going to have a side chain of CH2, COO minus. This is going to have a side chain of CH, CH2, CH2, COO minus. Now, we also have, for our most nonpolar and most hydrophobic, that was our isoleucine. This is our isoleucine, and an example of that, of our most and you also have valine as well. And you have leucine. So that's going to be so yeah, for a phosphorylated possible, that means that they can be and then I want to draw attention to these three. So these three they emit light when hit with the UV. That's phenylalanine, PHE, tryptophan, trip, and triazine, tire. And that's because of the benzene ring, which is aromatic. So this now I want to point out a buffer. In histidine. Now what's significant about this and what it means by it can serve as a buffer is that as body pH, which is around approximately 7.40. So that's why it can serve as a buffer. Now finally, proline and glycine. I want to draw some attention to these two. So these are helix breakers.